Okay, this lesson is on linear versus nonlinear functions. A linear function is a function that will make a straight line when it is graphed. An equation is linear if it can be written in the form of y equals mx plus b, where m is the slope and b is the y-intercept. We've already gone over that in previous lessons, so that should not look new. And then a table is linear if it shows a constant rate of change throughout the entire table. So make sure you have these notes down, and then we'll move forward. Okay, on number 1, we have a table and we have this equation, y equals x squared plus 1. We were given x values and we have to find the corresponding y value. So we're trying to make an ordered pair. So we're going to use our input and put that in for x and work this out, and then we will get our output. Okay, so if we put in a -2 for x and we square it, -2 times -2 is +4, plus 1 would be 5. All right, then we're going to take -1 and we're going to plug it in for x. So -1 times -1 is +1, plus 1 would be 2. And then we're going to continue, plug in 0. 0 squared, 0 times 0 is still 0, plus 1 would give me 1. Plug in the 1. 1 squared, 1 times 1 is 1, plus 1 would be 2. And lastly, plug in the 2. 2 squared, 2 times 2 is 4, plus 1 would be 5. After you've finished your input-output table, now you're going to plot these points. So our first ordered pair is right here. This is -2, 5. So the x value of -2 and a y value of 5. So we always start right here at our origin, and this is our x-axis. Make sure you pay attention, x-axis and y-axis. So we have to go on the x-axis to -2, and then the y value is 5. So we go left to -2. We always go left or right first because we have to go on the, use our x value first, and then we'll go up or down. Okay, so we go to -2 and then +5, which is right there, and we put our point. Okay, our next one is -1, +2. So we go back to the origin and we go -1, +2, and we put our point right there. Okay, then we're going to plot the point 0, 1, which is 0. We don't move right or left, and then 1, we go straight up. And then +1, +2, so we go right 1, and then up 2. And then 2, 5, so right 2 and up 5. There we go. All right, the question that follows this says, is the function linear, y or y not? Well, how do we know if it's linear? If we go up here to our notes, it says a linear function is a function that will make a straight line. Is this a straight line? No, it is not. So, is the function linear? No. The graph is not a straight line. And then we're going to add one more thing. And the table does not show a constant. You could write rate of change, but I'm running out of room. A constant slope. Remember, we were able to we could, if we tried to see what the slope is, we could look at our table and see up here it says a table's linear if it shows a constant rate of change throughout the entire table. Now, remember, the rate of change is the difference in your y's over the difference in your x's. Like if we go right here and we look at our y's, 5 minus 2 would be 3. and 2 minus 1 would be 1. So that looks like we have a slope of 3 over 1. But if we use this pair, 2 minus 1 would be 1, and the difference here is 1, and that's 1 over 1, which is 1. So using these pairs, we get a slope of 3, but if we use these pairs, we get a slope of 1. And that won't happen if it's a line. If it's a line, the slope will be constant. It will be the same no matter what ordered pairs you use. All right, let's go look at number 2. All right, number 2, the equation is y equals 1/2 x. Now, you can look at it as 1/2 x. You could look at it as well if you wanted to as 0.5x. It does not matter. Whenever you're multiplying something by 1/2, you're really just, if you're taking half of something, you're dividing it by 2. So this one will be pretty easy. If we look first at our x value of -4, and we take half of that, half of 4 would be 2, but it's going to be negative, because 1/2 is a positive number times -4, which is a negative number, gives us a negative number. All right, half of -2 would be -1. If we did 1/2 times 0, that's just 0. 1/2 times 2, half of 2 is 1. And 1/2 times 4, half of 4 is 2. All right, go plot those points. Remember, you go right or left first, and then up or down. All right, is the function linear, why or why not? Well, does it look like a line? Yes, it does. So we're going to say yes. The graph is a straight line. And let's look at the table. If we look at the table and we try to find the slope, if we look at y over x, 2 over 4 is 1/2. Same thing here, 1 over 2 is 1/2. -1 over -2 is 1/2. So we also have a constant rate of change. So we say, and the table shows a constant rate of change. All right, what do you notice that is different about the functions in question 1 and 2? Well, we have noticed that in question 1, we have in question 1, we don't have a constant rate of change. Like if we do our y over our x, 5 over 2, 5 divided by 2 would be 2.5, but then 2 over 1 is 2. So it's not the same when we look at our y over our x. Versus this one, it had a constant rate of change. But look at the equation. Do you see in this one, we have an x squared?
Good Friday morning,
Oops,
Fox
there goes
Academy.
the announcements.
Please stand for the pledge.
Okay, sorry about that. So the excuse me, the difference in the equations, if you look, is we have, do you see this x squared right here? That when you have the x raised to an exponent, it's not going to be linear. So we need to write something along those lines. Let's see, we could say in equation number 1, the x has a power greater than 1. All right, that's different than number 2, because if you look at number 2 and you look at the x, it doesn't look like it has a power. It does have a power of 1, but that's okay. That will still be linear. But if it has a power greater than 1, it's not going to be linear. Okay, we're gonna do some more of these, all right? So hopefully you're getting a little faster at plotting the points and that sort of thing. So we're gonna take the -2 for my x value and I'm gonna plug it in here. Now, pay attention because we're cubing it. So what that means is we're gonna do -2 times -2 times -2. Well, a -2 times a -2 is 4, positive 4. So this is positive 4, but then times another -2, a positive times a negative is gonna be a -8, okay? Then we're going to do -1. So if we do -1 times -1, that's a positive 1, times another -1 would be a -1. And then 0 times 0 times 0 is just 0. Then we have 1 times 1 times 1, which is just 1. And 2 times 2 times 2, what would that be? It would be 8. Okay, go plot your points. So -2, -8 is easy. -1, -1, you can go left 1, but then -1, see how it's going by 2s? So you're going to have to go left -1 and then down about a half of a way to -1 right here. All right, and then we have 0, 0, and then the same thing, right 1 and then up 1, which is really only about halfway, and then 2, 8. Okay. So, look at that function. Does it look linear? Does it look like a line? So we're going to say no. The graph is not a straight line. And the rate of change is not constant, which we're going to check that. But if it's not a straight line, it's not going to have a constant rate. So if you look right here, like 8 divided by 2 is 4, but then 1 over 1 is just 1. So, well, actually, look here. So 8 minus 1 would be 7 over 2, which is 3.5. But if we go here, that's 1 over 1, which is just 1. You can pretty much tell just from the graph, assuming that you graph it correctly. You should be fine. You can also, yeah, I would look at like kind of what you're counting by. Let's look at number 4. Okay, so, and you can use a calculator. So if we have to start with -4 and plug that in, you're going to do 1.5 times -4 in your calculator, and then add 2, and you get -4. Now, if you want to pause this and go ahead and try to fill out the rest of this table, that would be awesome to see how you're doing. Okay. When we plug in -2 into the calculator, and I really want you to practice doing it, you get -1. When you plug in 0, well, 1.5 times 0 is 0, plus 2 is 2. And when you plug in 2, well, 1.5 times 2, you know what 1.5 and 1.5, that'd be 3, right? Plus 2 would be 5. And then the last one is 8. So go plot those points. Okay, so does that look linear when you graph it? The answer is yes. So we need to go, it looks linear from the graph, but let's check to make sure it's linear in the table. So we look at our difference in our y's over our difference in our x's. So 8 minus 5 is 3, and 4 minus 2 is 2, so that's 3 over 2. And then if we come to this pair, 5 minus 2 would be 3 over, that's a difference of 2. And then 3 over a difference of 2. So it has a constant rate. So we can say yes, and we can say graph is a line, and table has a constant rate. All right, number 5, y equals 12 divided by x. All right, so all we're doing is putting the 1 in there for x. Okay, so 12 divided by 1 is just 12. And then put the 2 in, 12 divided by 2, which is 6. 12 divided by 3, which is 4. 12 divided by 4 is 3, and 12 divided by 6 is 2. All right, go plot those points. So that looks like that line got smashed, doesn't it? Because it's like, whoop, just like this. Okay. That's a different type of function. So is it a line? Is it linear? No. So we say graph is not a line. But we also need to double check that the table is not constant, which it shouldn't be. But if we look at the difference, here we have 6. So 12 minus 6 is 6, and 1 minus 2 will be -1. So 6 over -1, which is like a -6. But then if we go here, we get 2 over -1, and then 1 over -1. So it just keeps changing. So it does not have a constant. Graph is not a line, and table does not have a constant rate. All right, number 6. What differences did you notice about the equations that were linear functions and those that were not? If you go back and look at the equations, the ones that were linear and the ones, so this one's linear and these are not. Do you see that if it's linear, it's got an x to the first power, but if it's not linear, it's got another power or it's in the denominator. So those are ways for us to tell. So we're going to say any equation where x has a power greater than 1 or is in the denominator, the equation is not linear. Equations written in y equals mx plus b are linear. But pay attention, that x has a power 1. It can't be like 5x squared plus 2. Yeah. All right, number 7. What differences did you notice about the tables that were linear functions and those that weren't? So we've been writing this down. So we would just say tables with a constant rate of change are linear, but tables that did not have a constant rate of change were not linear. Okay. hopefully you can see the difference between a linear function and one that's not linear. It's really easy to look at the graph. I mean, if the points look like a line, it's linear. The only other thing you need to do in case you didn't have a graph would be if you look at the equation, see it's not linear if the x is in the denominator. It's not linear if the x has an exponent other than 1. This x, if you don't see it, has an exponent of 1, so it's linear. If we go back, to these, see how this has an x squared? Not linear. This just has an x to the first power, so it's linear. So you should be able to tell from a graph, from an equation, and then from a table. You look to see if there's a constant slope. You pick 2 points, you find the slope. Then you pick 2 other points and find the slope and see if it's the same. If it's not, then that means it's not linear. It's one of these other graphs. It might look like this. It might look like this one, or it might be like this. All right, thank you very much.